Welcome to Precalculus Concept 26a underneath trig functions of any angle. We are going to use the definition of trig functions to solve for any angle of theta, not just any angles on the unit circle, but any sort of point in the coordinate plane. 3 boxes, so here we go. I'm just going to start off with an example for you because really nothing changes other than the fact that our r value is no longer a 1. On the unit circle, the r value, which was the radius, was always 1, so things became really easy. Like sine theta was just y divided by 1, cosine theta was x divided by 1. Well, now that we're breaking out of the unit circle and we can have any point in the quadrant in the coordinate plane, we just have an r value. So let's just take, for example, let's let P be the point -3, -5, be a point on the terminal side of theta. Find all 6 trig functions of theta. So I took this picture straight from the book to show you what is happening, what's being illustrated. In the other examples, I'm going to ask you to draw the picture yourself. So let's consider where the point -3, -5 is. Okay, so if I draw a coordinate plane, I will go over 3, 1, 2, 3, and then down 5. So notice that I have this point here. Now, notice that it's very capable to draw a right triangle in quadrant number 3. This is where my angle terminates. So I have the value of the x is -3. I have the value of the y would be -5. What I need to get then is the value of r, which is this distance here, the radius. And of course, we all know that r is just going to be the square root of x squared plus y squared because it comes straight from the Pythagorean theorem and geometry. So pretty easy to do. So that must mean r is the square root of -3 squared plus -5 quantity squared. So then r is just the square root of, this is going to be 9 and 25. So therefore r is, move over here, adjust so we can get a little bigger. Here we go. Yeah. So then r is just going to be the square root of 9 and 25 is 34. So you can leave it just like that as the square root of 34. So now that we know what the value of r is, and we know what the value of x and y is, we can go ahead and fill in what we need to. The sine of theta is the value of y divided by r, so in this case it's going to be -5 divided by the square root of 34. But of course we rationalize to get -5, rad 34 over 34. Easy. The cosine is going to be -3 over rad 34. Rationalizing gives me -3 rad 34 over 34. So like that. Tangent is the y to the x value, so I have those were given in the problem over here. So that's just going to be -5 divided by -3, which gives me a positive 5/3. Now once we have those 3, we can easily use the reciprocal identities to find the others. So the cotangent is going to be 3/5. The secant is going to be the negative rad 34 over 3. And then the cosecant is going to be negative rad 34 over 5. And that's really all there is to it. Okay, box number 2 is another example. Let's do this one together from start to finish. Let P be the point 1, -3 on the terminal side of theta. Find all 6 trig functions of theta. Okay, so I want all of us to start the same way. Let's first consider where is this point, 1, -3. Hopefully you realize that that is somewhere in quadrant number 4. I'm going to go over 1 and then down 3, 1, 2, 3. So this is the angle that I'm talking about. There's my angle theta because it's positive. We always draw the triangle back to the x-axis. So if I draw this a little bit bigger so we can see, okay, my right triangle would look like this. This would be a value of 1. This is a value of -3, only because I'm in quadrant number 4. So I'm going to call this a value of r since I'm no longer on the unit circle. So r is the square root of x squared plus y squared. Again, that comes from geometry. So r is equal to the square root of 1 squared plus -3 squared. So therefore r is the square root of 1 plus 9. So r is the square root of 10. So you can leave it just like that, so we can't simplify that any further. Now we can go ahead and set ourselves up for success. I want sine theta equals. I want cosine theta equals. I want tangent of theta equals. I want cotangent of theta, secant of theta, and then cosecant of theta. Okay, sine is the y value to the r value. the y value in this case, so here's my x and here's my y, so it's going to be negative 3 over radical 10. But of course we know what to do, negative 3 rad 10 over 10. Cosine value is the x to r ratio. So the x is the 1, so this is going to be 1 over rad 10. But of course that's just going to be 1 times rad 10 over 10. The tangent of theta is the y to x ratio. So this is going to be negative 3 over 1. Now that I have the top 3, I can use the reciprocal identity and get the bottom 3. So this is going to be negative 1/3. This is going to be just the square root of 10. This is going to be the square root of 10 divided by negative 3. And there you go. Okay, box number 3, a u-try. Let negative 12, 5 be a point on the terminal side of theta. Find the secant of theta. Since this is a u-try, you can only plug in 1. So I want you to draw the picture, find the value of r, and tell me what the secant of theta is. Make sure that you have drawn the picture correctly in the right quadrant to represent the problem. Okay, hopefully you guys got the right answer here. I drew the problem in quadrant number 2. I went negative 12 to the left, and then I went 5 up. And so I found my r value by taking the square root of x squared plus y squared. I got a value of 13. And I asked you guys to find the secant only. So the secant of theta is the ratio of r to x. So that would be a value of 13 to negative 12. So the answer is negative 13/12.